This is Steve Piloff from George Mason University. Sometimes we have a case where we have an annuity or an annuity due. And what do we know? We know the present value. So we know the value of all the payments. We know the rate. We know what the amount of the regular cash flow is. And we want to know is how many payments, how many annuity payments, how many annuity due payments are associated with this annuity. And this comes up in a couple of common cases is you borrow some money and then you have to make a fixed payment, every month, every quarter, every year for whatever the increment for the loan is, and you want to know how many of those payments are going to be needed to pay off the loan. Another one is you've got an initial amount of money, you retire with a certain amount, you start college in a certain amount, and let's say you're in retirement and you want to know how, you want to take off a certain amount, $50,000 per year. How many of those withdrawals can you take from that account before it runs out of money? And we're going to focus on using the financial calculator to do that work for us. But you can do it algebraically as well, much more cumbersome. Before getting into that, a lot of times when we solve these problems, you come up with a number of payments that's not a whole number. 1.59, 11.20, 22.4, and you come up with a fractional payment. And so it's helpful to think about how we can interpret it. Think of it as roughly the portion of a regular payment that must be made as the last payment. So here's a little example. So we take out a loan of Z dollars, and every year we're going to make a payment of X dollars. And we say, okay, how many payments of X dollars do we need to make such that the present value of what we're going to pay is equal to the opposite of Z, such that we get Z and what we're giving back is equal in value. And we see it's 2.3 payments. A way to think about that is that we're going to make our first payment of X, our second payment of X, and then our last payment of 0.3X. And so that's just a good general way to think about it. When we're solving our problems, the answer would be 2.3. So the problems are the number of payments, and we can think of it as 2.3. The number that's on the calculator is the answer, because it's basically, you don't want to outthink it and say, oh, it's 3 payments because it's X, X, and 0.3X. It's X and X, which are full payments, and then 0.3X, so the number of payments would be 2.3. So with the calculator, you give it the PV, so you give it the present value of the annuity or annuity due. Remember to sign convention, so it's actually going to be the opposite of the present value of the cash flows. You're going to give it I%, which is the rate that we're going to discount by. You give it PMT, which is the amount of the payment, and then you put it in end mode, and it tells the calculator, okay, that first of those payments is in one period. You can give it FV, but we're not going to do that in this class because it doesn't lend itself to a nice common sense type of question. We may have an extra payment at some specific point in time, like we might say time 4, or also at time t, we've got an extra payment, but we can deal with those, and we'll have examples that do that. But we're not going to have an FE out there. That'll always be 0 in these kinds of problems. And so the calculator will then find the number of payments such that the present value of all of these guys is equal to the opposite of PV. So, it's payment over 1 plus I% there. Nope, you still need more. Go to second, third, you do as many as you need, and then it'll figure out how many you need. In begin mode, everything's the same, except that the first payment's here, the second's here, the third's there, the fourth's there. You give it PV, you give it I%, and it'll say, okay, if we make our first payment, does it get us to pay off our loan? Nope. How about our second? Or is payment, the PMT, equal to negative PV? No, it's still too low. Try the second one, third one. How many do we need in order such that the present value of all this stuff is equivalent to what we tell it should be? So let's take a look at an example. You borrow $20,000, rate of 6/10 per month. Your monthly payment's $300. So every month you're going to pay $300. Your first payment's due today, so 300, 300, 300 for as long as you need to. And the question is, how many loan payments will you make? And so basically what we're looking for, since we're borrowing 20, is how many of these payments do we need such their present value is equal to negative 20,000. And you can see we pay our first loan, or our first loan payment negative 300. That's certainly a lot less than negative 20,000. Negative 300 over 1.006 plus negative 300, that's still too low, and so it's going to be a bunch of payments. So we're in begin mode, we're paying $300. We need the present value of all those $300 to equal negative 20,000, discounted by 0.6%, nothing extra at the end, and we see that we need to make 84.73 payments. That's the answer, 84.73. Similar problem, same borrowing, same monthly payment, same monthly rate, same question, how many loan payments, but your first payment is due in 1 month. 2, 3, so how many of these do we need such their present value is equal to negative 20 to offset the loan? So the setup is pretty similar, but since the first payment's due in 1 month, we're in end mode, payment's 300, PV of 20, so basically we're going to discount rate of 0.6. We want to know if we're discounting all of these 300s by 0.6%, and the first one starts in 1 year, or 1 month, how many do we need such that the present value of all of them is equal to negative 20,000? And the answer to that is 85.39. And notice when we start making our payments in 1 month, we wind up needing a slightly larger number of payments because the loan has an opportunity to accrue some interest on a bigger amount of money. If we have 20 and we start payments right away, we're immediately down to 19.7, so there's less interest accruing on the loan, and so our $300 payments will get us to the end of the loan with a little fewer number of payments.